Hey there, so we're going to keep looking at Chapter 6, talking about proofs by contradiction. And we've got another problem set here, and I will do another one as an example. So here we're looking at a problem involving divisibility, so get yourself ready for notes, and we're going to get started. So let a and b be integers where a is greater than or equal to 2. Then a doesn't divide b or a doesn't divide b plus 1. So one sign that we're probably not going to want to use direct proof, that we'll use contradiction or contrapositive, is that we have these negatives here. And I, in this case, of course, am going to use contradiction, which means that the first thing I want to do is say that the thing we want to prove is false. So in this case, we will start by saying that a and b are in the integers, and that a is greater than or equal to 2. And we're going to say that a does divide b and a divides b plus 1. Now this is an important point that I feel like I didn't make strongly enough the first time we looked at negating things. The opposite of or is and. So these are the negations here. If I want to negate something like this, it has to, okay, well then they're both true in this case. So make sure that you're keeping your eye out for that. So what we can then say is since a divides b, then b is equal to ax, and since a divides b plus 1, we can say b plus 1 is equal to ay, where x and y are integers. From there, one thing that we want to try to do is arrive at some sort of logical fallacy. So this is where we're going to start maybe doing a little playing around. That doesn't mean you know exactly where things are going to end up, but we're going to work with that. One thing that I would think to do is, okay, well, what happens here when I can add or subtract, because that's going to cancel out these b's. So that's exactly what I'm going to do here. I'm going to say, well, b plus 1 minus b, and see if I can arrive into something odd with 1 there. And on the other side, it would be ay minus ax. So we're just doing straight up substitution. So then 1 is equal to a times y minus x. Now what's important here is that since a and y minus x are both in the integers, because of closure under subtraction, and we know that they multiply to 1, that means a is equal to plus or minus 1, and y minus x is equal to plus or minus 1. Now, we're not so worried about this term here. However, we did start this entire proof by saying a is greater than or equal to 2. So if a is equal to plus or minus 1, but we started with a is greater than or equal to 2, this is our point of contradiction right here. And so therefore our initial supposition must be incorrect. So therefore we have a contradiction. And a cannot divide b, or a cannot divide b plus 1. So hopefully this is another example of contradiction. Made sense. This one's going to be a more similar idea to most of your proofs by contradiction, since it has these negations of different operations. But that could also mean that contrapositive might be a good choice as well. Let me know in the forum or in a Zoom call or in comments if there's anything that you have questions on or are stuck on, and I am happy and ready to help. Talk to you later.